Maybe we ought to think about it, Oppie sighed as he ambled away, as only Oppie could in his crazy but characteristic gait.
Hello, and welcome to the National Security Science Podcast, which is the podcast for the National Security Science magazine. We are recording from Los Alamos National Laboratory in beautiful northern New Mexico. Our current magazine is all about J. Robert Oppenheimer, which I highly recommend if you'd like to know more about Oppenheimer. And for today's story, we will tell the story of one of Oppenheimer's close colleagues, someone Oppenheimer personally recruited to the Manhattan Project. I'm your host, Brenda Fleming, and today's co-host is National Security Science writer Weston Phippen. Weston, thanks for joining me today.
Really glad to be here, Brenda. Thanks.
So today you're going to read something for us.
Yeah, today I'm going to read an article called A Reluctant Division Leader, and it was written by Robert Wilson. Now, Wilson was selected by Oppenheimer as the very first physics division leader after World War II, and it was a role that Wilson really didn't want. Wilson, he wanted to do science because he was a scientist, and he didn't want to manage people, but he only accepted the role after some gentle prodding by Enrico Fermi.
Yes, he sounds very reluctant. He used the phrase, "sell my soul." So, to our audience, who was Enrico Fermi?
Enrico Fermi was a physicist, and he was known as the architect of the nuclear age because he developed the first nuclear reactor, and he also won a Nobel Prize.
So, he was a pretty smart guy, and Wilson talks about how excited he was when he caught Fermi in error. Now, Weston, one thing that struck me in listening to this story is that Wilson talks about going to the Trinity site at one point and helping people casually stack high explosives for a test where 100 tons of TNT are detonated. And we actually have pictures of this in our National Security Science magazine in the history issue, the 2020 history issue. There are people walking on a sea of boxes labeled high explosives. It's very nerve-wracking to look at. But it's pretty cool because Wilson talks about that moment. But Weston, what was happening at Trinity Site? Why did Wilson visit Trinity Site before the Trinity test?
So the Trinity test was the first full-scale nuclear test, which happened in May 1945. But before the Trinity test, scientists needed to get test diagnostics, so they detonated 100 tons of TNT. So Wilson was there because he had worked to develop various signal detectors, which would later be used in the Trinity test. And I think he also just thought that seeing the explosion might be a valuable experience. As for the walking on TNT boxes, Wilson talks about this a bit, and I also think we give them a little credit because they were scientists and they probably knew what they were doing.
Well, thanks, Weston, for joining us. We look forward to the story, but before we start, let's welcome National Security Science writer Jill Gibson for today's Labcast, a minute to spotlight current achievements at Los Alamos.
Thanks, Brenda. On today's Labcast, 10 Los Alamos projects have won innovation awards, considered the Oscars of innovation, honoring the best inventions of the past year. 9 Los Alamos-led technologies received what are called R&D 100 awards, and Los Alamos also partnered on a 10th R&D 100 award led by Argonne National Laboratory. You can read all about the winners on the lab webpage, but today we'll highlight 2 chosen because they have the best acronyms. Let's start with NACHO. Of course, that stands for Nano-Satellite Atmospheric Chemistry Hyperspectral Observation System. NACHO. This is the first CubeSat-based hyperspectral imaging system to deliver trace gas detection capabilities in a small, lightweight package. The second best acronym award goes to CANDLE. This stands for Cancer Distributed Learning Environment. That's software that applies machine learning and deep learning techniques to large-scale cancer data sets to accelerate the discovery of new cancer therapies and treatments. Check out all the winners on the Los Alamos National Laboratory webpage.
And now here's Weston with Robert Wilson's A Reluctant Division Leader.
No, 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 I won't do it, I shouted at Oppenheimer, who had just offered me the job of heading the new research division at Los Alamos. The year was 1944, and the laboratory was being reorganized because of the discovery of the high rate of spontaneous fission in plutonium. Bob Batcher headed the old experimental physics division, which had been split into two new divisions in August of that year. One part became Gadget Division, which was to develop a plutonium bomb based on Seth Nedemeyer's implosion ideas. The other part became R Division, which would consist of the remaining four groups from the experimental physics division: the cyclotron group, headed by me, the electrostatic group, headed by John Williams, the DD group, headed by John Manley, and the radioactivity group. Look, Oppie, just pick one of the other three group leaders. They're all much more senior than I am, and each would hate working for a young fellow like me, I explained. Not as easy as you think, responded Oppie. I have already tried to pick, in turn, each one of them, but in each case the other two threaten to quit, so you, Bob, are elected. No, not me. I didn't come here to be an administrator. Why don't you just bite the bullet, choose one, and let the chips fall where they may, I responded. I thought I had done just that in selecting you, Oppie said weakly. Well, bite a different bullet then, because I came here to do physics and not to become an administrator, I replied, looking him straight in the eye at the implied criticism. Maybe we ought to think about it, Oppie sighed as he ambled away, as only Oppie could in his crazy but characteristic gait. The next day, Enrico Fermi asked me to accompany him on a walk. He had been sent by Oppie to talk me into the R Division job. You're a fine friend, I said after hearing him out, for I have been following your example and turning it down. You would never do that sort of thing. Fermi's eyes sparkled. It's something you have to earn, and you're not Fermi yet. He then went on to instruct me on how to avoid administrative duties. Essentially, it came down to just saying no. Yeah, but how about all the technical work of the other groups? Wouldn't I need to know about it in detail, I asked? I was, up to this point, doing a pretty good job of saying no to Fermi when suddenly he volunteered to help me with the technical work. I was astounded. I could hardly believe my ears. The idea of working with Fermi made it a whole new ballgame. I had worked with him on the reactor project at Columbia University, so I knew what a valuable experience working and learning from Fermi could be. Never mind all the delightful fun of just being with him. Fermi promised that he would be available whenever a problem came up. To clinch our bargain, we agreed to meet together every Friday after lunch to discuss the physics being done in the division and also the physics that should be done. I was ready at that point to sell my soul for this chance, but I still had a few conditions for Oppenheimer. One was that I could continue as group leader of the cyclotron group. Another was that I not have a special office with a secretary. Only occasionally would I argue with Fermi's physics, and then only with great trepidation. He was just terribly good. I did learn a lot because he worked out what he was doing in a very clear manner that I could easily follow. Yet being human, I wanted to participate more in the physics process. I do remember once, though, when, to my great satisfaction, I caught him in an egregious error. Then, without remorse, I made him suffer for being right so much of the time. This joyous occasion occurred when I had invented a device for measuring the rate of increase of neutrons, the E-folding time. During the explosion of the bomb, an electron multiplier tube was to be used to measure the radiation as it emerged from the detonation of the bomb. Fermi thought about this for a few seconds, went through his calculations, and then informed me that it would not work. Too slow, he said with his usual confidence. I informed him that that must be wrong. Again, Fermi went through his calculations, this time out loud and slowly for my benefit. My dear Enrico, you are losing your grip. Perhaps it's too elementary, I said with an assurance that worried Fermi slightly. He made more calculations, this time on a piece of paper, again with the wrong result. He had made an error that I knew he was not likely to find. That put me for once in the catbird seat. Fermi's error was due to our custom at Los Alamos of finding a particle's speed at some energy by simply scaling up that of a thermal neutron. Fermi had been doing this automatically over the past years, and he was not likely to break out of this ingrained habit. I let him wallow in his misconception, while I privately delighted at his discomfort. Eventually, I asked him, to his embarrassment, if he had ever heard that electrons were 1,800 times less massive than neutrons. We tended at first to be somewhat casual about the Trinity test. One day, John Dwyer and I were discussing possible electrical pickup signals in the various detectors being built. We knew that the next day there would be a test explosion of 100 tons of TNT at the site of the future test. We asked ourselves whether or not we could find out anything from the explosion. Well, no, we decided, but just seeing it might be a valuable experience for us, or at least some fun. So on a whim, we called Oppie's office to tell the guards at Trinity site that we were on our way. Then we put a portable electric generator, a long coil of electric cable, and an oscilloscope into a pickup truck, stopped to tell our wives we did not have telephones in our private homes, and headed for Trinity site some 200 miles to the south. It was dark when we got there, and we had to talk our way into the site past the guards. We were able to spend the night in the crude barracks at the base camp. The next morning, we drove over to where about a dozen people were stacking a huge pile of boxes of TNT. We joined in and helped stack boxes for a while. Strangely, no one else seemed worried about dropping a box because, I gathered, a detonator was required to start an explosion. But I was worried. Soon, I had an idea for our experiment. Simply to put the shorted end of our cable deep into the pile and then run the cable 700 feet away from the pile to our oscilloscope and gasoline-powered generator. Not much of an experiment, I must say, but it was better than stacking boxes of TNT. Of course, we expected no signal. That night, we found the explosion impressive. It even had a quality of beauty. The next morning, we developed the photograph, which had automatically been made of the scope trace. To our surprise, there were huge signals. We had to understand the source of those signals, how much worse they would be in the ambience of an exploding atomic bomb 100 times more powerful, and how we should shield against them. This unexpected finding was a good example of the value of laziness and fear. Back at Los Alamos, significantly large amounts of separated uranium-235 began to arrive from Tennessee. One experiment that I can recall was to measure the multiplication of neutrons in a sphere of this material about 1 inch in diameter. Oppie insisted that the material be guarded at all time, and for some reason, Fermi's personal guard, John Bodino, was assigned to us. In fact, there were 2 identical spheres, one of uranium-235 and the other of normal uranium. We were to make a comparison of the two. I like to amuse myself by switching the spheres around rapidly and then asking Bodino which sphere was the one he was guarding. He would confess that he did not know. I could tell because the uranium-235 was warmer because of its greater radioactivity. We wanted the measurements to go on all night, but we had to stop so that Bodino could sleep. I had the idea that were I to be issued a pistol, then I could do all the guarding myself. After all, I came from Wyoming, where every red-blooded boy learned to shoot before he could walk. Oppie agreed and asked security to issue me a pistol. My friend, Pierre da Silva, agreed to do so, but he reasonably insisted that I be checked out first on whether in fact I could safely use a pistol. This he did by taking me to the firing range, pulling out a .38 Colt police revolver and giving me a lecture on its use. This little lever is the trigger. These little gadgets are cartridges and should be put in these holes that spin around here. You line up in front of the gun with this V-shaped hickey in the back and with what you are shooting at. Here, I'll show you, Da Silva said. With that, he carefully fired 6 shots at a target. Now you do it, he said, loading the gun. I had learned in Wyoming to roll a pistol in order to get a lot of shots off accurately and rapidly. That's just what I did. Most of my shots were closer to the bullseye than his were. None of this fazed Da Silva in the slightest. He repeated his earlier lecture in its entirety, together with his demonstration. He finally wrote out a beginner's certification and issued the revolver to me for the duration of the experiment. He had put on a terrific show. Not once did he crack a smile. I took full advantage of the pistol to impress my friends with what a macho type I was. I carried it ostentatiously tucked into my belt, everywhere in the technical area, and spent no little time at all explaining to the military police why I had a gun. Eventually, I had to show them De Silva's authorization. When the experiment was completed a week or so later, I was most reluctant to give it back. I am proud to this day that the uranium spheres had not been stolen on my watch. The Trinity test was soon upon us. Our division had occupied the north bunker at 10,000 yards from the bomb locality and had acquitted themselves well. Not that any credit was due to me, but I still take great pride in them. However, Trinity is a separate story. Once we had seen the explosion in all its grandeur and implied horror, we did not need any of our measurements to know that it was a success. They would have been more meaningful had it failed. I exulted with my colleagues in the gratification we felt in a job that had taken 5 long years of dedicated, hard work. It was an epiphany for all of us. For what had been theoretical before had now become all too real, but in a different way for each one of us. For me, the project was over. I could hardly wait for John Manley to take over the division and to reorganize it into the physics division that now bears little resemblance to the tiny group we were then. Do I regret my fall from grace? From being a pure physicist to becoming an administrator of sorts? No. If Paris were worth a mass, as Henry V had said, then surely Fermi was worth my fall from grace.
Thank you, Weston. That concludes our story, but before we go, let's take a minute for a highlight from the Hill. Today we have the Bradbury Science Museum director Linda Deck reading us a poem about saying goodbye to Los Alamos after the war. The poem was written by members of the Women's Army Corps, or WAC, during the Manhattan Project. They titled it A Farewell from the WACs. Here is Linda.
August 1946, A Farewell from the WACs. In 43, the company began with a few to help man the site. But the number increased till we had enough wax to give any poor GI a fright. We've eaten the dust in the windy months and sloshed in mud over our feet. And if we ever stumble on rocks again, we hope they're in rings, not on the street. We've jostled on buses for hours on end just to shop in a so-called big store. And we've waited for pictures to change at the show to be told no more room at the door. There were times when we've griped and complained quite a bit, but now when we know where to go, it's going to be hard to leave the old place and all of the people we know. We wish we were clever and could think of a way to gracefully say fond adieu. But our feeble attempts would fall short of our aim and no doubt on the drippy side too. So long to the company. We'll miss it, we know, and the friends who have helped us each way. We're sorry that we're leaving, but sincerely hope that we'll all meet again someday.
Special thanks to the Los Alamos Historical Society, which published the WAC poems in a book called Life Within Limits by Eleanor Roach, and also to the Historical Society Executive Director Todd Nichols, who helped organize the poem readings in Oppenheimer's Los Alamos home, and to all those who participated in our event where we recorded. And thank you so much for listening to the National Security Science Podcast. Don't forget to check out the National Security Science magazine online at lanel.gov/magazine to learn more about how better science equals better national security. For more great stories from Los Alamos, including several other podcasts, video series, and interactive stories, visit discover.lanel.gov.